In this video, we're going to be looking at limits. So limits are useful when differentiating by first principles as well as getting understanding of differentiation, and you're going to see them a lot more if you do any further mathematics after this course. So firstly, what is a limit? Well, a limit of a function at a particular point is a value that function approaches as it approaches that particular x value. So that's a pretty wordy definition, but basically what a limit is what that value approaches. So let's say we're going along here with this line, and you say, what's this next value going to be? Well, the next value is going to be a certain value, and that's because we approach it, and then we can go from the other side. And if we start looking, we can see that looking at both sides, we're going to approach this particular value. So a limit's different to what the function actually is, as what the function is defined by the equation, but the limit is what it approaches. So the key word here is you're talking about it approaching from sort of like either side and about what value it approaches. So it's quite useful, we won't use it in this course, but finding the limit of a function when it goes to infinity. Because we can't actually work out sometimes when the function goes to infinity, it's good to know what value it approaches. Because as x gets bigger and bigger and bigger and bigger, we don't know exactly what value it would be, but we can work out what it will approach. So the limit of a function at a particular point, so let's say we want to find the limit of that, because there'll be different limits at every different x value for the function. So that's what I'm talking about at a particular point. So we can say, let's say x is equal to 2. And then is the value the function approaches as it approaches that particular x value. So what I'm saying that here is we'll put x equals 2 into the definition. So the limit of a function at x equals 2 is the value that function approaches at x equals 2. So that's saying that if that was x is equal to 2, what value does this function approach? So it does seem a bit similar to what the function actually equals, and that's because for continuous functions, so continuous you can think about is if a function where you never have to lift your pen off the paper. So it keeps on going, that's all continuous, but as soon as you have to lift off and you have to start again, then it's not continuous, it's discontinuous. So for a continuous function, the limit of, let's say, x of a of fx, so that's this notation, the limit of x approaching a is just equal to f a. So that's just saying that the limit is always equal to what the function equals for continuous graphs. So when we go through a few examples, you'll see some discontinuous graphs where the limit does not equal the actual value or the limit does not exist. So first, looking at this line, we have y is equal to x plus 1. So what about if we want to know what does the limit of x equal when it approaches 2 for this fx, this equation? Well, we can go at 2, and we can go up here and see what is this point here? Well, this is 2, 3. Now, what is the limit? What does it approach? Well, if we go from the left-hand side, so we start from the left-hand side, and we can see that using this equation, it's going to approach 3. Okay, and then now we go for the right-hand side. And as it goes from right-hand side, it approaches 3. So as they approach from both sides, then we know the limit of x going to 2 fx is equal to 3. However, as we know it's continuous, a straight line is continuous in this example, unless they're stated otherwise, then we could have just subbed in the value, which that's how I got the points 2, 3 there. But what about if we now have an equation here, which is discontinuous? So this could be a hybrid function, for example. So what about if we want to find the limit of x approaching 1? So firstly, what does f1 equal? Well, f1 is equal to 0. That's because there's an open circle there and a closed circle there. So obviously the closed circle is the one that is included in x is equal to 1, and the y value is 0. So f1 is equal to 0, and that's the equation. So what does it approach though? Well, if we go from the left-hand side, if we come up, 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 then we don't exactly go into that point, but it approaches 4. So we say left-hand side is equal to 4. What about the right-hand side? So we go right-hand side, and then it approaches 0. So it equals 0. So as the left-hand side does not equal the right-hand side, so as they both don't approach one value, the limit does not exist. So the limit of x1 does not exist. Right, so what about this function this line here. So we can put a line, actually, put a dot up here where you have 3, 6. So with this function, it would have to be a hybrid function. Let's put that point in, and it's 6 at x equals 3. So for all the domain, there's a value. You have it as x plus 1, apart from when x is equal to 3, and when x is equal to 3, it's 6. So if we wanted to go, let's say, f0, then we'd get the value of 1. If we went f10, we'd get the value of 11, and if we went f3, we'd get the value of 6. So those two, I use the equation, and then for f3, it equals 6. But what does the limit of x approaching 3 equal? Well, if we go from the left-hand side, we can see that it starts to approach the value 4. So left-hand side approaches 4. We go from the right-hand side, and then it approaches 4, because it doesn't suddenly jump up and approach this value up here. So the right-hand side is equal to 4. So as the left-hand side is equal to the right-hand side, whatever this value is the limit. So the limit of x going to 3 is equal to 4. So this is an example where the limit does exist, however the limit does not equal the actual value of the equation. So in the previous example, the limit didn't exist, like that, and in this example the limit did exist, but it wasn't the exact same as the equation. And that's because this graph is not continuous, so we can't say for certain that the limits are equal to the equation. So here we have a question, not looking at the graph, but we just have the equation. So how can we solve this? The limit of x going to 3, x squared plus 4. Well, that's a quadratic, and we know that a quadratic is always going to be continuous. So what I can say here is that the limit of x to 3, x approaching 3, x squared plus 4 is just equal to f3. So it's equal to 3 squared plus 4, which is equal to 9 plus 4, which is equal to 13. So now the limit of x to 3 of this equation is equal to 13. What about this question though? So the limit of x going to 2, x squared minus 5x plus 6 over x minus 2. Now, we can't, even though the top is a quadratic, there's a denominator which has an x term. So you can't, generally don't assume it's continuous, and in this case it's actually not. So what happens if we sub in the value 2? So we sub in the value 2, we get 2 squared minus 5x plus 6 over 2 minus 2. So that is equal to, it should have been times 2. So we get 4 minus 10 plus 6 over 0. So that means it's undefined. So it doesn't exist there. So obviously it's not going to be continuous. So we can't just sub in 2. So this is a typical example. So when you see the x to the power of 2 divided by x, you should think, is there a way to simplify this? So x squared minus 5x plus 6. Well, x squared minus 5x plus 6 is equal to x minus 2, x minus 3. Then we can go x minus 2, x minus 3, divided by x minus 2. So these can cancel. However, x cannot equal 2. So that's a rule that when you cancel two numbers, that's only for when those numbers don't equal 0. And that's because you have to say that x cannot equal 2, because when x does equal 2, this function is undefined. So if x minus 2, x minus 3. So when you have like equation, let's say this 7 times x over 7, you just cancel those and it just equals x. But that's fine, because 7 never equals 0. But if you have an equation, let's say x times y over x, and you cancel the x's, then you have to say that x times y over x is equal to y when x does not equal 0. Because when x does equal 0, the function is undefined. So that's a really important note to make. However, now we've simplified the equation, we've seen that x minus 3, but x cannot equal 2. So if fx is equal to x minus 3, x cannot equal 2. So what this is going to look like, it will be a straight line coming down here and then going through here, but it just will have an open circle at x cannot equal 2. So we have this line here. So what does this mean? Well, we know it's undefined at x equals 2, but that doesn't mean that the limit is not defined. So we go on the left-hand side and we see it approaches 2. So the left-hand side is equal to 2. We go from the right-hand side, we see that the right-hand side is equal to 2. So we know that the limit approaches 2. So the limit of x going to 2 of x squared minus 5x plus 6 over x minus 2 is equal to 2. So that's probably the tricky question you can get with a limit, where if you sub it in, it's not defined. However, you can cancel it out, simplify it, and then you can sub that value in. You can sub x is equal to 2 into this equation. Okay, I've actually made a mistake here, and that's because it doesn't approach 2. That's the x value here. So if we simplify this, just forget about that and just go back to here. And we simplified it, and we got that x minus 2, x minus 3 over x minus 2 is equal to x minus 3 when x cannot equal 2. So graphically, the equation looks like this. We have fx is equal to x minus 3, but x cannot equal 2, so there's an open hole there. Now if you go from the left-hand side, we see that it approaches negative 1. So I said 2 before, but that I was just getting confused with what x is equal to. So left-hand side is equal to negative 1. And the right-hand side also approaches negative 1. So as they both approach the same value, then it approaches negative 1. So we can say, going back to this, that the limit of x going to 2, x squared minus 5x plus 6 over x minus 2 is equal to negative 1. Even though it's not defined, even though f2 is not defined. The limit is still defined, and we can work it out by cancelling there. This doesn't matter this doesn't affect the limit, so we can just look at x minus 3, sub in x is equal to 2 to x minus 3, and we get the value to the limit is equal to negative 1.